Hello everyone, my name is Ray, and welcome to Storytelling from the AWS Cloud. For those of you who are unfamiliar with Framestore, up on the screen here I have a timeline of some of our company history and some of our milestones. We are an award-winning global creative studio working across film, episodic, advertising, AR, MR, VR, and theme park rides. The company was founded in 1986 by 5 people. Today, we are 3,000 across 8 locations in 5 countries, and we're dedicated to our passion for digital storytelling. Next up for you, I have a reel of some of our highlights. That reel only took us 30 years to make. So who am I? My name is Ray, and I'm from the other side of the continent, in New York City. Actually the same place where Spider-Man is from, Queens. And this is my first time ever leaving the United States. I've been with Framestore since 2015, where I started off as a tech runner, moving physical desktops and racking and stacking server hardware so much that I became a server myself. Looking in the crowd, I see some of you guys are from New York, and those of you from New York will know that we only have 2 seasons, summer and winter. And those summer days are brutally hot. And I remember, and I'm sure some of you remember as well, having to run up to the roof and spray down your aircon unit, praying it'll help you lower the temps in your server room. Sometimes it did, but when it didn't, this is when you start pausing your renders, powering down servers, and all production stops until your aircon is repaired. So naturally, I felt there had to be a better way of doing things. So I became interested in the cloud. But back then, physical hardware was still preferred and trusted by engineers, and the cloud was just a buzzword. But I did not let that stop me, as I was still interested in virtualization and software-defined computing. Thankfully, Framestore always promotes self-learning. And once I passed my exams and proved AWS would work for us in a production environment by architecting our first render and workstation deployments in AWS, which I'll show you later, they recognized my passion for the cloud and created a role for me where I became their very first dedicated cloud engineer. Pause for applause. In 2020, over the course of a few weeks, we all needed to move our staff to working 100% remotely. But since we were already interested in looking at the cloud, we were better prepared for the effects of the global pandemic, which created additional business needs and new technical problems that needed to be solved. So what were these business needs? Work from home meant we were no longer limited to physical seats. As everyone was connecting via PCIP remotely, we could scale up our staff. And since we had more staff, we were able to take on more projects at a time. And because of this, during the pandemic, the New York office where I'm from expanded by 25%. So naturally, we outgrew our footprint. We were at physical machine capacity in the office. The server rooms were filled, and you can only put so many towers on the floor. Additionally, we were restricted by available power and cooling, and expanding our server room at the time was cost prohibitive. Yet, shows still needed to be delivered, artists needed to work, and we had 2 massive jobs starting within 2 weeks. Needless to say, we needed a solution as soon as possible so we could provide our artists with the tools they need to continue our passion for digital storytelling. A lot of us engineers in the VFX field are faced with these short time frames on almost a daily basis. However, because of the pandemic and the business needs that stemmed from it, we knew we needed to innovate. We needed to improve the way we deploy machines so we can deliver these 2 massive jobs and solve our problem of being only dependent on physical infrastructure. Traditionally, we would buy more machines ahead of time or rent them for the time we needed. But due to the global supply chain issues, when trying to buy these machines, we're faced with long lead times, which in some cases were upwards of a year. And when it came to renting machines, our hardware vendors were also facing these supply chain issues. So prices were often inflated or even sometimes uncertain. Even if we could get more machines via buying or renting, they would not arrive in time for our 2-week deadline, and not help us in the fact that we were still limited by available power and cooling. So traditional methods would not solve our problems and help us deliver these 2 massive jobs. So we looked to see what the cloud would offer. The cloud would offer us elasticity, allowing us to grow and shrink our infrastructure so we can create Framestore resources around the world and clean them up when they're no longer needed. It would also offer us scalability. And as many of you know in the VFX industry, a job can quickly balloon much larger than we first anticipated. But with over 500 instance sizes to choose from, we're able to scale up and choose instances with more RAM or CPU when needed, or scale out and continue to parallelize our workload beyond our on-prem capacity. And as many of you know, it's also highly available. With many regions around the world, we're able to ensure each Framestore office uses the regions closest to them, allowing them to split their workload not only across multiple availability zones, but multiple regions as well. And one of the most important things the cloud offered us was cost efficiency. Way back when I first started looking at the cloud, one of the most popular opinions was that it was too expensive. However, in VFX, many of our workloads are actually burstable. We have spurts throughout the year where you're very busy, then you're not busy. And during those times where you're not busy, those machines are just sitting there chilling. But with a pay-as-you-go model, you can burst into the cloud whenever you need, and like a light switch, turn it off when it's no longer needed. And it's because of these offerings, we considered how our business strategy would change. Our OpEx costs would now begin to complement our CapEx investments, allowing for additional financial flexibility. We're no longer limited to available physical infrastructure, as we can scale our office into the cloud whenever we would want. And engineering time would be greatly reduced, as resources are now only an API call away, allowing us to deploy render and workstation in seconds rather than days or weeks. No more will we have to wait for hardware to come in and spend valuable engineering time on provisioning it. And additionally, the cost savings would also be affected by the cost savings would also affect our business strategy. We would not need to pay for additional rack space or power and cooling, or worry about our machines thermal throttling on those hot summer days. And because we chose to scale into AWS for our compute needs, we achieved 80% cost reduction when compared to renting physical workstations. And because we are connecting remotely, we're not limited to staff in a specific geographic area, as we could now scale our workforce farther than our initial reach. So what did we need to consider when scaling to AWS? At Framestore, our main storage is on-prem, and all cloud storage would be considered ephemeral. So all we needed to look at was the network and the available instances. AWS Direct Connect offers us a low-latency, fast connection to their services, and it's because of this all Framestore sites in the US have at least, all Framestore sites in the US via our cloud connection broker have at least 10 gig networking to the cloud. And it's via that 10 gig networking that we built our VPC in a hybrid model, extending our Framestore network into the cloud. So our resources in the cloud would benefit from that that low latency, fast connection to our resources on-prem. And when it came to the instances, AWS offers G4DN and G5 instances, which artists can use as workstations. These instances provide Intel or AMD CPUs with NVIDIA graphics passed through to them, that in some cases matched or even surpassed the specs of machines we had available on-prem. Additionally, they support the AVX2 instruction set, so we're able to offer them via PCIP to our artists. Therefore, the artist's workflow would not need to change. They can connect to a machine in the cloud the same exact way they connect to a machine on-prem. And when it came to render compute, we use C, M, and R family instances, which also offer us some of the latest CPUs from Intel or AMD. And since our workload is recoverable, we're able to utilize spot instances and save up to 90% on instance render costs. And in order to meet our desired capacity, we use auto-scaling to spread our workload across multiple availability zones. And because we scale this way, our Framestore offices in the US are able to get tens of thousands of cores in the cloud. But that's not it. These instances are special, as they're ran on AWS's Nitro hypervisor. With the move to a KVM-based hypervisor from Xen, they got rid of DOM0, the initial domain that's created when a hypervisor starts, which handles drivers, storage, and networking. But those things still need to happen somewhere. So AWS created custom silicon to offload this virtualization overhead too, which you'll see in this picture up here. But what that means to us is that storage, networking, management, and security all happen on these separate Nitro cards. And to us as consumers, that means when you're getting a machine or an instance, you're getting near metal or even bare metal performance. So an artist cannot tell the difference between a machine in the cloud versus a machine on-prem. So how did we build it, though? We used Terraform and GitLab to deploy our VPCs globally. This gave us change management and consistent deployments, allowing us to ensure our VPCs are deployed following our security best practices. And before we can do that, we needed to get our Framestore images into the cloud. So we pixie booted a VMware guest and tailored it to our needs by removing the packages and drivers needed for physical hardware and included those that were needed for the cloud, such as the latest ENA or EFA drivers. And once that VM was tailored to our needs, we simply just copied the VMDK to S3 and used VM import to easily to convert it to an AMI, which we could scale. And because we use familiar tool structures and API calls, machine deployment time greatly decreased as engineers are easily able to provision instances using our instance creation tools. Additionally, we created a web interface to empower artists and empower team leads to manage their own cloud workstation and scale cloud render on their own, reducing support overhead from our engineering team. As mentioned before, Framestore's main storage is located on-prem, so we needed a way to efficiently present that storage to our instances in the cloud. By using kernel NFS and cache files D, which offered us an open source write-through NFS cache that operates in kernel space. This allowed us to offer reads of our on-premise storage as close as possible to our instances in the cloud by replicating data when an NFS client requests it. So the first read comes directly from on-prem, but all subsequent reads of that same data is served from our cache in the cloud. And since it is a write-through cache, all writes are forwarded directly back on-prem, mitigating the need to have to sync writes. And by using the cache, we're better able to manage bandwidth. If every render instance was pulling the same image at the same time, we would saturate our uplink to the cloud. But because we're using a cache, we no longer need to, that operation doesn't have to happen. We're pulling it from on-prem. And we mitigate the additional I/O overhead from our back-end storage. And because we're able to efficiently present our on-prem storage as close as possible, to our cloud instances, we decrease application and pipeline load times for both our artists and our render. So now you know how we did it. But what's the cloud's future at Framestore? We'd like to include AWS as a cloud provider across all Framestore sites globally, giving us the ability to offer workstations and render to production on demand. And we'd like to burst into the cloud for other departments, moving production, finance, HR, and data services workloads to the cloud. And further along our cloud journey, we'd like to incorporate AWS autoscaling directly into Framestore's Queue Manager, FQ, which will give us the ability to better manage our costs and capacity and have our render farm breathe on its own. A lot of the work that we do as engineers tends to go unseen, not because we are not artists, as I'm sure some of us are, but because the work we do tends to operate in the background so we can give the artists the tools they need to create the magic. During the pandemic, delivering those tools presented us with new challenges, but because we faced those challenges head-on by bursting into the AWS Cloud for workstations and render, we were able to meet demand and give our artists the tools they needed to begin working on those two massive jobs. And this spot that I'm about to play for you is one of those massive jobs. And for me, as an engineer, it holds a special place in my heart, as the work that I've done directly contributes to you seeing it on the screen.
Let's get together. Let's turn things around. Me and you, together we can.
Life really got sweeter because we were able to scale into the cloud and continue Framestore's passion for digital storytelling. Thank you, everyone. My name is Ray.